worksheet 12A, and I suggest you to practice and see the solution for worksheet 12C before we move for 12A. The same stress block in 12C, and in this case we have sigma x given equal to it in compression, so 14,000 psi, sigma y in tension, so it's positive 1,000 psi. Tau x y is opposite to the positive y-axis in analytical method is equal to negative 500 psi. For all objects, you may check the solution worksheet 12C where what is the size of sigma x, sigma y, and tau xy were explained more carefully in that. So the question in this 12A is determine the principal stresses and show the orientation of the planes on which they act. So go ahead to find out the principal stresses. Principal stresses. This is sigma 1 and sigma 2. And here with the equation we already have sigma 1 equal to sigma x plus sigma y over 2, which is sigma average plus square root sigma x minus sigma y over 2 square plus tau xy square. So basically this is equal to sigma average plus tau max from the equation we have. We can plug in sigma 1 equal to R already given for negative 14,000 plus 1,000 psi divided by 2 plus square root of negative 14,100 minus 1,000 divided by 2 square plus tau xy negative 500 square, and it equal to two components. We have negative 200 plus in the square root we got 1,300. So bottom line we have sigma 1 equal to 1,100 psi. One answer. And sigma 2, of course, instead of plus we put the negative. So sigma 2 equal to sigma average negative tau max in equation plus minus tau max, and that equal to, from that equation and number above, we have 1,200 minus 1,300. So sigma 2 equal to negative 1,500 psi, and that also the answer for the second principal stress. And of course, for the principal stresses, we have tau, the shear stress, equal to 0. The question on also asks, so the orientation of the plane on which they act.